Good day. Once again, you are welcome to Success Enlightenment. Hi, this is Ishala Dedeji Mike, and we will continue our basic econometrics proving. Basic econometrics identity proving. In our previous video, we already started the basic econometrics identity proving, where we took our time to prove. Eight major econometrics identity. Here we will continue with the basic econometrics identity proving. We must not forget our previous proving was based on already established statistical facts, such as our small letter x equals to what? Capital letter x minus capital letter s bar, which is the same thing as the mean of x. This is a deviation of x, y, the capital letter s stands for what? The observable data about the variable x. And in the same way, our small letter y, same thing as capital letter y minus what? Y bar. Also, we record that summation, we record that s bar, which is the mean of s, equals to summation x over n, and y bar, which is the mean of capital letter y, which is equal to summation y over n, and we record that k equals what? X all over summation s squared. Alright, we use this very basic identity to prove certain econometrics identity, such as summation small letter x equals to 0, summation small letter y equals to 0, summation k equals to 0, summation k x equals to 1, summation k squared equals to what? 1 over summation s squared. Summation x y equals to summation x small letter y equals to summation small letter s capital letter y equals to n summation x y minus summation x summation y. Alright, do we see that? Alright. We also use it to prove that summation s squared equals to n summation s squared minus summation x all squared. Also used to prove that summation k small letter y equals to what? Summation k capital letter y. 1, 2, 3, 4, 5, 6, 7, 8. These all are proved based on what we already established. Fact like this, we used to prove this. So furthermore, in this video, we'll be proving our further econometrics identity. Right? Don't just watch the video, like, subscribe to the channel. Feel free, my contact is attached to this video. Feel free to message me if you encounter any problem while you are attempting to prove any of these identities on your own. The mastery of this identity is very, very, very important for undergraduate economic studies. All right, especially 300 level undergraduate econometrics study. All right, without more verbosity, without waste of our time with too much of words. All right, let's go right into it. Welcome once again to Success Enlightenment. Let's go into it. Alright, in this video, we're proving this 7 econometrics identity will be proved in this video. Alright, this 7 econometrics identity will be proved in this video. Alright, we are going to prove that our small letter y estimate is equal to what? Beta cap x. Small letter y estimate is equal to beta cap x. Alright, small letter y estimate is equal to beta cap x. Alright, that's what we are going to prove here. We are going to prove that beta cap square summation small letter s square equals to beta cap summation small letter x y. And we are going to prove that beta cap, the cap there means estimate, the estimation of beta. Alright, beta is a parameter. Alright, when we get to our simple regression analysis or least square analysis, we are going to have this more understanding. But let's just start from here as we proceed further. Alright, beta cap summation s square equals to what? Summation small letter s y. We are going to prove that summation ku equals to 0. We already know what's our k. Our k is what? S over summation s square. We are going to prove that summation of this KU is equal to 0, and we are also going to prove that summation U small letter s equals to 0. Likewise, we prove that summation y cap u equals to 0. Then finally, we are going to prove that what t squared, that is t squared, the square of t statistics, all right, the square of t statistics equals to what, f statistics, all right. And we are given, all right, this, we already know what our t statistics. T statistics is what, is our beta cap divided by what, standard deviation of what, of our beta cap, all right. We already know what our standard deviation of beta cap. Standard deviation is what, is the square root of what, variance. So therefore our variance will be square of standard deviation of beta cap, and our variance is what, is sigma squared divided by summation s squared. Now what is sigma squared? Sigma squared is what, summation e squared all over n minus q, where e is a what, is a residual, all right, is a residual, all right. And then our f statistics from our knowledge of ANOVA table, f statistics is what, is beta cap summation sy divided by k minus 1 if that minus 1 is when you are dealing with what, a linear regression in one variable, linear regression in one variable, all right. If it is two variable, this will be what, k minus 2, that will be multi regression. Now once you are dealing with simple linear regression, that's one variable to by k minus 1, but with this multiple regression with two variables, that will be k minus 2, with three variable k minus 3, all right. And divided by what, summation e squared, that is sum of residual square all over n minus k, all right, n minus k. We already know what's our k, all right. So we are also given what's the y estimate. Y small letter y estimate is same thing as what, the capital letter y estimate minus the y bar, that is the mean of the y. So our y capital letter y estimate is what, is estimate of the alpha square plus beta square x, all right. That's what that is, right. These are basic what, as OLS estimate, simple regression analysis estimate. Then what is your y bar? Your y bar is what, with the alpha cap plus beta cap over what, y cap plus beta cap s bar. That's your what, that's your y bar. Then what is your beta cap? Our beta cap using derivation approach with summation sy over summation s squared. All these are given, all right. With all these that are given, we have to prove every single individual identities here. You have to prove every single individual identity here, all right. This is very, very important in most examination case and test case. These are most likely what you will see, all right. They might not bring any question out from the previous one I proved. It might be majorly this and this. The last one here, t squared equals to f statistics, t statistics squared equals to the f statistics, is very, 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 very important. So also is every other identity is very, very important. All of them, they're important. The mastery of what, econometrics what, algebra. So I'll take my time here and I'll prove them one after the other. I'll make it as simple, as succinct as possible. Let's get right into it. All right, our first proving today is we have to prove that the estimate of small letter y cap, that is deviation of y, is equals to what, the beta cap estimate small letter x, beta cap estimate small letter s. All right, the first thing we have to state is our intention, which is what, to prove. All right, I've already made this clear. Before you can prove something, there are some basic established facts you already know. So therefore, we are going to recall. Now we can prove from the right to the left or from the left to the right. But in this case, we prove from the word from the left to the right. Recall that our y cap, our small letter y cap. What is our small letter y cap from what we are given? What's our small letter y cap? Remember, I stated some identities earlier. So from that identity, small letter y cap is equal to capital letter y cap minus what? Capital letter y bar. Okay? So now, this is our small letter y. Alright, now we need to know what is capital letter y bar, y cap, and what is capital letter y bar. Now, our capital letter y cap is what? Alpha cap plus beta cap x, capital letter x. Don't forget this one is capital letter x. Y, our y bar, capital letter y bar, not small letter y, equals what? Alpha cap plus beta cap s bar. Are we getting it? So from here now, all we have to do is just substitute this and this into this. All right. You substitute this and this into this. All right. If this is equation one, let's say this is equation one. Let's say this is two. Let's say this is three. So what we do is what we substitute equation two and three in equation one to get what our small letter y cap is. So therefore, our small letter y cap then be what? Alpha cap plus beta cap, capital letter x, minus alpha cap plus beta cap s bar. Don't forget to at first put this in bracket. The minus sign you see there is enough to what? To confuse a lot of students. So do not make the mistake, right? Be careful whenever you see minus in any of your mathematical, statistical, econometrics service. All right. So going from here, what do we have? Your y cap here will then be what? Alpha cap plus beta cap x minus alpha cap minus beta cap x bar. All right. So from here, this take this out. This cancel that. So our y, sorry, the y cap will then be what? Beta cap, capital letter x minus what? Beta cap s bar. So from here, what can you do? You can factorize beta cap. So factorize beta cap at the right hand side. Okay. So then your small letter y cap will then be equal to what? Beta cap into what? S minus what? S bar. Alright. So from here you can recall again. Recall that small letter s is equal to what? Capital S minus what? S bar, which is same thing as this. So therefore this is same thing as small letter s. So therefore your y cap equals to what? Is equals to beta cap small letter s. So your y cap equals to what? Beta cap small letter s. Proved. See how simple it is? So we just prove our first identity. It is as simple as that. All you have to do is what? You state your motive first. Don't forget this is the procedure. Don't mistake it. Don't forget to make it what? In the procedure. Mathematics is a what? Mathematics, statistics, econometrics, they are all discipline of what? Principle. So when you are solving in exam situations, all right, the principle must always be observed. All right. The first thing is what? To prove. Then you recall. All right. These are what you need. All right. You can even add this to this. All right. You can even add this to this. You can state them, all of them. So when you recall, find this what you are solving. So for you to solve, you need to know this and this. So what these are this. All right. So when you substitute this for this, all right. So all you simply do is what? You open this bracket. Then you must be careful with the minus. Okay. So when you open the bracket, this alpha cap and minus alpha cap take each other out. All right. That will be 0. Then what you are left with what is beta cap s minus beta cap s bar. So you simply factorize the what? The beta cap out of it. So when you factorize this beta cap out of it, what you are left out is what? The beta cap into bracket s minus s bar, and s minus s bar is same thing as small letter x. So when you put that here, what you have is what? Is your y cap so the beta cap s, which is what you are asked to prove originally. It doesn't get any easier than that. Let's go straight into proving what the next econometrics identity will be proven. Let's go straight. All right, this is the second basic econometrics identity will be proven in this video. Right, we look at it. We have proved that what? Beta cap square summation s square is equals to what? Beta cap summation s y. Everything s and y here in small letter. All right. So the first thing we need to do is we have to recall. All right. We have to recall what is our beta cap itself. All right. So beta cap itself is equals to what? Summation sy all over summation s square. So we move from the what? From the left hand side to right hand side here as well. So from here now, all right. From here now, we substitute this for beta cap. That is, so our beta cap square summation s square then equals what? Summation sy summation s square square summation s square. All right, we just substitute this for beta cap. So now we can open this. This will give us what? This will give us what? Summation xy summation xy all over what? Summation s square summation s square times summation s square. All right. this definitely we take one of these out. All right, this we cancel one of these. So therefore, our beta cap square summation s square we what summation sy summation sy all over what summation s square. So this can be written, right? This can be written as summation sy summation s square times what summation xy. Recall that this summation sy summation s square is empty as what our beta cap here. All right, this is empty as this. So therefore, we can write this as what? Beta cap square summation s square equals to this is as beta cap. So this is as what? Beta cap summation sy, which is exactly what we are asked to prove, isn't it? Yes, it is. So therefore, we are done with this proving. So it is proved. See how simple it is. Very, very simple and straightforward. Many times, something like this come out. And the very thing is, forget when I was solving, I forget to state the motive. So the first thing you state is what? Is to prove. Okay? Don't forget. Please, to prove, then you go with your word, your recall. You are not solving, you are proving. Okay? So you have to make them understand that you are proving. It is, you have to simplify, state it to simplify. Alright? Don't worry. This is mathematics is a system of what? Of procedures. And once you miss the steppings, you miss your mark. Okay? So all you have to do is you call what's a beta cap. So once you put it in there, is square, fine. That is, you have this twice. Okay, you have this like this. You take one of these out. So definitely what you have left is this. You same thing as this, and this is your what? Your beta cap. Okay, so if this is your beta cap, so definitely this is beta cap summation s y. We are done with the second proving. So now we go into the word into the next econometrics identity that will be proven in this video. I believe this is as simple as anything, as it is very, very simple. Okay, so let's continue. All right, the third one we'll be proving today is what? Is beta cap summation s squared equals to what? Summation x y. Similar to what we just proved, only that here our beta cap doesn't have a square. So let's get right into it. The first thing we do is what? We state our motive, which is what? To prove. So we recall that what? Beta cap equals what? Summation sy all over summation s squared. So we simply substitute this for beta cap. So therefore, our beta cap summation s squared is same thing as what? Summation sy all over summation s squared times summation s squared. Alright? So this definitely we cancel this. So therefore, our beta cap summation s squared equals to what? Summation xy. Since this we take this out. Good. See how simple it is? Very, very simple. Very, very simple. 1, 2, 3, 4, 5. Just 5 or see about 6 lines. You are done with this proving. Let's go straight to the next one. So we don't take our time. Let's go to the next one. Alright, so now we have to prove that summation EKU is equal to 0. Our U is a residual and is an error term. So summation K times 0 times equals to 0. So now all we have to do is first state our motive, which is to prove. We have to recall what is our K. Our K equals to what? X all over summation s squared. What is our U? Our U equals to what? Small letter y minus what? Small letter y cap. Okay? Now already from our first proving, we already established our y cap equals to what? Equal to beta cap x. That's our first proving. Alright, so from here, let's go ahead and substitute this value and make our proving. Alright, so summation KU will then be what? Let's first find our KU. Let's take the summation out. So KU will then be what? X all over summation s squared into what? Y minus what? Small letter y. Y minus what? Y cap. Okay? Y minus y cap. So from here, this will be what? The value of y cap is what? Is beta cap x. So therefore, this is same thing as what? X into summation s squared into what? Y minus what? Beta cap x. So now we can bring the summation into it. or let's expand this bracket. Either ways, this will give us what is xy. This will be sy minus what beta cap s square. This s times s all over what summation s square. So now our summation ku now we now have what summation into this. This will give us what summation xy minus what beta cap summation s square all over summation s square. Now from our proving, from our previous proving, we already know that, recall that from our previous building, we already find that what beta cap summation s square equals what summation xy. Alright, we've already found this. So therefore, just substitute this for what beta cap summation s square. So therefore, our what our summation ku equals to what summation sy minus summation sy all over summation s square. So this minus this gives you 0. So summation ku equals to 0 all over summation s square. Anything divided by 0 mathematically is undivided, but 0 divided by anything is equals to what? 0. So therefore, summation ku equals to 0 proved. This is what you are asked to prove. It's as simple as that. All you have to have is what? Those basic established facts. You must know them. Alright, you can't afford to forget them, because if once you forget them, you have a problem here. You need them in what? Improving all this. See how it is? You have to recall what's your k, your u, and what is this. Alright, so you just make the substitution. You open this bracket. When you open this bracket, this is what you find eventually when you bring the summation to it. But don't forget, this beta cap summation s square is also an identity. We proved it. That our beta cap summation s square equals what? Summation xy. So just put this inside this, right? And then you are here. Alright, the reason why I didn't solve this in the first video is that this might require what? You use some of already proven identities again in what? Improving this. That's why I decided that let me make this a separate video from the other one. But they are very, very simple and straightforward. Without wasting much time, let's go to the what? To the fifth proving. Let's go to the fifth proving. Alright, the fifth one we'll be proving is what? Summation ux equals to 0. That is sum of the error term and derivation of x is equals to 0. Alright, from here what we have to do is what? Is state a multiple, which is to prove. Then we have to recall u equals to what? Small letter y minus y cap. And our y cap equals to what? Is beta cap x. So therefore, from here, our ux will be what? Our ux will be what? Will be y minus y cap into what? X. Don't forget, this can be substituted for this. So therefore, is equals to what? Y minus what? Beta cap x into what? Into x. So let's open this bracket. Our ux equals to what? Small letter yx, let's say xy, let's say this xy, minus what? Beta cap s square. Now put summation to it, because we are looking for summation ux equals what? Summation xy minus what? Beta cap summation s square. Now recall, from here we have to recall that what? Beta cap summation s square equals what? Summation xy. Already proving this to be truth and valid. So therefore, our summation ux equals what? Summation xy. Substitute this for this minus what? Summation sy. So therefore, our summation us equals to 0. This is what we are asked to prove, and we have what? We have proved it. This is the proof. This is the proof here. Very, very simple. All you have to do is what? Recall what's your u, what's this. Then when you substitute this, there you open the bracket, you print the solution, then you are here, then you have to recall what this is. These cancel each other, and we have what? Summation us equals to 0. Very simple and straightforward. So let's get to the next one. We are almost done. This is the fifth. We are almost done. Alright, here we have to prove that summation y cap u is equals to 0. The same procedure. So to prove, we have to recall y cap equals to what? It's beta cap x. Yu equals to small letter y minus what? Small letter y estimate. Okay, so now from here we have to substitute. So our summation y cap u equals to what? What's our y? Which is what? Beta cap. Don't forget the summation in bracket, right? Y cap u is equal to what? Is beta cap x into what? Y minus y cap. Alright, we can still substitute this for this here. So therefore, this equals to what? Summation into what? Beta cap x into what? Y minus what? Beta cap x. So now we can open this bracket by multiplying all through by beta cap x first. So therefore, we have summation into what? Beta cap sy minus beta cap square s square. Alright? So now we can put the summation all through. So therefore, our summation y cap u will then be equals to beta cap summation xy minus what? Beta cap square summation s square. Now here we have to recall our first very proving, which is that we have to recall that beta cap square summation s square equals what? Beta cap summation x y. We have to recall this. Right? We have to recall this. We prove this ourselves. This is what we prove ourselves. So therefore we can substitute this for this. So therefore our summation y cap u then equals to what? Beta cap summation xy minus beta cap summation sy. So this will give you what? 0. So therefore our summation y cap u equals what? 0, which is what we are asked to prove. It is thereby proved. Very, very simple. Okay, it's very simple and straightforward. So now we're done with the first 6, and we have just one more proving to do, which is we have to prove that our t statistics square equals to our f statistics. Alright, this is the last proving we'll be proving in this video. This is the last representative we'll be covering in this video. So, alright, still the same procedure. So the first thing we state our motivation is what? To prove. So we have to recall what is our t square. Recall what is our t. Our t is beta cap. Beta cap all over what? Standard deviation of what? Beta cap. So what then is really t square? Our t square will now be what? Beta cap square all over what? Standard deviation of what? Beta cap square. Now recall that standard deviation of what? Beta cap square is written as what? Variance of what? Beta cap. So therefore our t square equals what? Beta cap square all over what? Variance of what? Beta cap. Now we still have to recall that our variance of beta cap equals what? Sigma square all over what? Summation s square. Equals to sigma square all over summation s square. So we have to substitute this in this. So therefore our beta cap square divided by this divided by what? Sigma square all over summation s square is empty as what? Beta cap square multiplied by summation s square all over sigma square. Now we have to recall what is our beta. Recall that our beta cap is same thing as what? Summation sy all over summation x square. So therefore we have to do this for beta cap. So therefore what we have is what? Summation sy all over summation s square, everything square times summation s square all over sigma square. This is empty as what? Summation sy all over summation s square times summation sy all over summation s square times summation s square all over sigma square. This take this out. Okay? This take this out. This is still the same thing as what as our beta cap, right? So therefore, what we have is what we have beta cap summation sy all over sigma square. Alright, sorry, beta cap summation. We have beta cap. Yes, this beta, this summation sy all over what sigma square. Now the thing is, question now is that what is our sigma square? So we have to recall that our sigma square, equals to what? Summation e square into what? N minus k. Okay, n minus k. So therefore, our beta cap summation xy, this beta cap, this beta, right? So substitute this for this, it be divided by what? Summation e square all over n minus k. Now since this is a simple linear regression, that is, there's only one independent variable, so we have to what? Divide this by what? K minus 1. Now if this has more than let's say it's a multiple regression, let's say with 2 independent variables be k minus 2, if it is 5 variables be k minus 5. All right, so because this is one variable, all right, one independent variable, that is, we have x, y is our dependent, y, x is our independent variable. So we have this to be beta cap summation sy over k minus 1 divided by our summation e square all over n minus 1. And from our ANOVA table, this is the value of our what? This is our f statistics. So therefore, we'll be able to prove that the square root of our t statistics, the square of our t statistic is equal to what? F statistics. So therefore, we have been able to prove successfully what the task we wanted to prove. Okay, we're ready to prove that our t square is equal to what? F statistics. Don't forget, here we are dealing with t statistics and f statistics. So the square of t statistics is equal to f statistics. This is very simple as ABC. You have to start by recalling what is your t statistics. Your t statistics is beta cap divided by what? Standard deviation of beta cap. So what is the t statistics square? So that will be what? Beta cap square all over standard deviation of beta cap square. And standard deviation of beta cap square is the same thing as what? Variance of beta. So therefore, your t square then equal to beta cap square all over variance of beta cap. Alright? So from there, you have to recall what really is the variance of beta cap. So the variance of beta cap is what? Is sigma square all over summation s square. So therefore, your t square will now be what? Beta cap square divided by sigma square all over summation s square. So when you express the division and you carry it out, before you do that, you can find what's your beta cap, because the beta cap is already identified. It's an identity which is equal to what? Summation xy all over summation s square. So when you substitute that there, you have your summation sy over summation s square times summation sy over summation s square times summation s square all over your sigma square. So in that way, s square will cancel s square. So you have summation, you have this which is your beta times summation sy divided by your sigma square. And what is sigma square? Sigma square is the same thing as what? Summation e square divided by what? N minus k. Alright, so therefore when you write it down, you have beta cap summation sy divided by summation e square over n minus k. This is n minus k. This is not 1. This is not 1. This is k. N minus k. Now, since we are dealing with simple linear regression, alright, so therefore it will now be what? Beta cap summation sy all over k minus 1. Simple linear regression with one independent variable divided by summation e square over n minus k. And this is your what? Is the proving that t statistics square is equal to f statistics. And with this, we come to the end of this video. We've come to the end of video on basic econometrics word proving, basic econometrics identity. Take your time and master the proving of each and every single identities I've proved here. If you encounter any identity different from this and you want to know how to prove it, feel free to contact me. My contact is here. Call me so you and I can learn together. Alright, in your study of this, if you encounter anything that I do that you don't understand, also feel free to contact me. I will be more than happy to explain to you on one-on-one. Alright, with that being said, don't just watch, like and comment, all right, and subscribe to this channel so that when next I make an enlightening content like this, you'll be the first to be notified as far as this channel is concerned. All right, now with this I come to the end of the video. I remain my humble self, Ishola Adedeji Michael, and this is Success Enlightenment. Until next time, we may enjoy every moment of your life. Thank you.